Enormous news. There's no perhaps about it. This planet is certainly the nearest planet to the Sun that is not circling the Sun. Earth is our heaven in space. Albeit 7 different planets, a plenty of moons, and endless more modest bantam planets make up our nearby planet group. The main planet that contains everything required for life, as far as we might be concerned, is Earth. Anyway, we are drawing near to when we could need to leave our cherished planet. This carries us to Proxima b, the Earth-like planet circling Proxima Centauri that we could one day call home. Yet, a disclosure made by the Webb Space Telescope has raised doubts and driven specialists to raise doubt about our implied presence of the planet circling Proxima Centauri. It very well might be clammy like Earth, and it seems and appears as though Earth, but is this planet our only any expectation of keeping away from what might some way or another be the sure obliteration of all that humankind has worked to achieve? Might we at some point live there? Go along with us as we investigate the James Webb Telescope's frightening revelation on Proxima b. Following 6 years, essentially every area in our planetary group was viewed as a likely territory for life. For many years, the discoveries from shuttle missions to different universes changed that viewpoint. Just the Moon, Mars, and perhaps a portion of the bigger moons of the Goliath planets Jupiter, Saturn, Uranus, and Neptune could uphold a drawn-out settlement. The Goliath planets themselves have no hard surfaces to stroll on. Also, a few of their moons are unfriendly to life. While people have visited Mars and the Moon, NASA research recommends that only Callisto, the larger moon of Jupiter, and Titan, the larger moon of Saturn, could be habitable for a lengthy time frame. Smaller moons of gas giants Jupiter and Saturn have such light gravity that a pilgrim's muscles would progressively weaken over time. Because of the intense radiation fields exuding from the gas giants that passes on us with Mercury and Venus. Due to its vicinity to the Sun, Mercury can't support life as far as we might be aware. It is showered in sun radiation and has a normal surface temperature of 800 degrees Fahrenheit. Venus is considerably more blazing than Mercury. Lead might be liquefied at the normal surface temperature. The air is multiple times more compressed than Earth's air, which is very excruciating. Might we at any point preclude the chance of outsider life? A huge part of the inspiration for space investigation is to find the response. Planets change, that much is sure. Earth today seems as though it did a long time back when life started. The development of Earth's surface by plate tectonics has made the landmasses we see today. A shift from carbon dioxide to nitrogen and oxygen has happened in the environment. The sea salinity has additionally changed since the beginning of time. Because of these progressions, all hints of life's beginnings have been eradicated. The world's attractive field is made by conductive materials situated in the focal point of the globe. Sun-oriented breeze, which is a strong breeze that could some way or another crash Earth's air, is repulsed by the attractive field. Auroras, for example, the popular aurora borealis, frequently known as aurora borealis, are shaped when a part of the sun-oriented breeze is redirected to the posts in a protected manner, making life and keeping it alive for a drawn-out time frame until it creates insight might rely upon these remarkable Earth characteristics or a blend of them. Stromatolites or fossil hills are among the early bits of proof of life on Earth. Oxygen was continuously added to Earth's air more than billions of years. Because of these animals' utilization of carbon dioxide and the ensuing arrival of oxygen as waste, life that blossomed with oxygen advanced. Researchers at our exhibition hall, NASA locales, and different labs across the world are as yet searching for indications of something going on under the surface. Beyond Earth, regardless of whether we haven't found any yet, there is other life out there, and we have endeavored to reach it. A metal record looking like a photo was among the earliest things sent off into space by people. The records alongside the perusing needle were conveyed by the Explorer 1 and 2 space apparatus that left from Earth in 1977. These records highlighted pictures and hints of life on Earth. Who knows whether somebody will one day hear it? The nearest tenable exoplanet is Proxima Centauri b, a ways off of 4.25 light-years. Given its closeness to its host star, the planet is logically flawlessly locked, confronting the star with a super-durable day side. What are the chances that Proxima b might uphold life? That fascinating subject continues to spring up. Harvard College physicist A.B.Y. Throw and cosmologist Laura Carberg proposed utilizing the JWST to find arrangements. Researchers can utilize the JWST to concentrate on designs that propose the presence of water or an air on Proxima b since it can catch infrared light shined off the surface. As space expert Ed Turner brings up, however, because something has a climate doesn't mean life exists there. Like Venus, Proxima b might have a thick air and scorching temperatures. Even yet, the strategy proposed by Hurl and Crabber is as yet our most prominent bet for getting a gander at this while investigating Proxima b. Scientists for the most part utilize infrared picture examination. The finding of extrasolar planets is made conceivable by the JWST imposing infrared vision which catches mirrored infrared light. Researchers can decide if Proxima b is surrounded by an air or contains water by dissecting these photos for designs. This revolutionary technique opens up a universe of possibilities and lays the preparation for future planetary exploration. Finding how much water is on Proxima b and whether it has an air are the essential objectives of the test. Possible tenability on Proxima b is helped by the likelihood of water on a superficial level. Moreover, an air might distribute intensity to the planet's clouded side while shielding it from the very sweltering surface. Deciding these components turns out to be fundamentally reliant upon the JWST infrared IM examination capacities. However, due to the intricacy of planetary atmospheres and the limits of current innovation, finding distinct answers is as yet tough. As per late estimations, the most profound openings of JWST would have the option to identify nuclear blasts on Proxima b that discharge energy identical to in excess of a megaton of dynamite. We could guide the telescope to search areas of strength for blasts on the nearest occupied planet, regardless of whether these were principally worried about tracking down the earliest stars in the early universe to direct a nuclear hunt to. Obstructions promptly come into view since atomic fights on Earth are so uncommon. The primary standard is that the blast and the observing time frame should concur in time. In the wake of representing the time it takes for light to travel second, how much energy delivered would be similar to that of hits with shooting stars bigger than 30 m. Such impacts happen just once like clockwork on Earth. No space rocks bigger than 98 foot will actually want to impact Proxima b during the JUS perception run, except if the planet is enclosed by a thick haze of them. Rocket dispatches are one more unconventional light source. The Starship rocket worked by Elon Musk's SpaceX is our most powerful rocket and uses numerous kilotons of methane fuel each send-off. Even at the distance of the nearest star Proxima Centauri, JWST cannot distinguish this, which is equivalent to a couple of % of a megaton of dynamite over a long send-off period. It is conceivable that these recognizing difficulties will determine FM's conundrum in a manner that is palatable, innovative signs that are all the more effectively discernible for KSF Type 2 and 3 civilizations which reap all the energy from their host star or system ought to be viewed as living in Fantasyland, much the same as Disney World's Mr. Perfect or The View, through the metaverse goggles where computer-generated reality meets our cravings. Normally a specialized DevX Earthbound visit offers the best possibilities of genuine location on the off chance that the outsider space apparatus was decommissioned billions of years prior. It would collide with Earth's air like a meteor with a strange piece and seem as though it came from one more planet. A few interstellar articles with especially incredible material strength could be sections of old broken Dyson circles. Accepting the unlikely presence of KSF Type 2 civilizations, air conditions are a vital sign of a planet's livability, yet they are not a confirmation that life exists there. As per stargazer Ed Turner, life as far as we might be aware can't exist in that frame of mind as thick as Venus. Subsequently, Proxima b's air alone doesn't lay out that the planet is tenable. To fully fathom this extraterrestrial planet, researchers should utilize a large number of procedures and observations to get a handle on the difficulties of researching exoplanets that could uphold life. It is important to contrast Proxima b with Venus has a far denser air than Earth, yet the gas giant still gets exceptionally warm. Tenability is a consequence of a large number of components collaborating in convoluted ways, as this model shows. Exploring Proxima b gives